Hello everyone, myself Virendra Kumar, and in this video you will learn about the relations and functions that is related to mathematics, IIT-JEE, and this topic is very much important for your academic as well. So let's learn about this. बच्चों, this topic is relevant to both class 11 and 12 because you know this text is related to class 11, but when you are going into the class 12, the first chapter itself of mathematics belongs to this. So that's why I thought that I should start from here for both of you, class 11 and 12, and this topic is important to the IIT JEE syllabus also, mathematics. So focus here. Let's start the video. Relations and functions. So, बच्चों, you know about the sets. I have discussed the sets and its different properties. Mainly in the last class, I discussed the union of sets, intersection of sets, and their representation via Venn diagram. And we will utilize those principles what we learned in the previous videos here to move further the topic relations and functions. So in our life, we are related to one and another by different relations you can imagine. And similarly, we can relate one items with another attributes very easily. Suppose we are wearing a shirt, so shirt of different sizes and different colors. If we are keeping the size as one attribute and color as another attribute, and we are combining and making the different combinations, then we can have number of what sets of shirts of particular size with the particular colors. So how can we arrange such type of combinations can be easily handled by the topic relations and functions. So let us begin with some text. Much of the mathematics is about finding a pattern, the recognizable link between quantities that change. In our daily life, we come across many patterns that characterize relations such as brother sister, father son, mother daughter, teacher students. Similarly, in mathematics also, we come across many relations such as number, such some number is less than a particular number, greater than particular number, and so on. So these are the things like suppose let m is greater than n. M and n both belongs to the natural number. So this is a kind of relation, greater than relation, less than relations. So that comes from the mathematics only, right? Line is parallel to line M, inclined to each other, and so on. Right, right. So in this chapter, we learn how to link pairs of objects from two sets and then suppose very good examples Cartesian product of sets. Suppose, that is the topic we are going to discuss in detail. Cartesian product of sets Cartesian product of set. Suppose here examples are given. Uh, is a set of three objects: color and particular bag, coat and shirt. Suppose if we are given a set A and B, set A represents the different color. Suppose red, green, blue, and you are having another set B of the objects like bag, coats, pants, like you are having such different two sets. Then can you create a combination by taking the two sets to have a special combination? So if you take the red color, so you can have the red color bag, red color coats, and red color pants, so that you can have another also combination: green bag, green coats, green pants, and blue bag, blue coats, and blue pants. Right. So this means that if you want to combine these two sets by some relations, you can have the particular items, objects, and you can realize that if you are combining the red color with the bag, so here the uh, order of red and bag matters, particularly in mathematics where we are dealing. It doesn't mean that bag plus red is same that bag red combination is not same as the red bag combination. So order matters. Okay. So how many items we can have by combining the two sets element? So the rule is simple. Suppose if you are two, how many colors you have? Three colors. I in my example it was three colors. In the book it is given two colors only. So R, G, and B, three colors and three items. So RGB and items were bag, then coat, and then pant. So if you want to combine by some orders, you can see that you can have the nine pairs: red, red, blue, red bag, red coat, red pants; green bag, green coat, and green pants; blue bag, blue coat, and blue pants. In this way, we can have the different sets of items, right? So that set, what we are having finally is known as the cross product and cross product of sets. So how can we have? So cross product of set is defined by A cross B, and it is the set of all elements. It is a set of all elements belonging to the set A and Y belonging to set B. You can see this very carefully. This is the cross product of two sets A and B. Set of all the elements of A and B in the particular order means here X is the element of A and Y is the element of B, and their order is fixed, right? Then these pairs, ordered pair, XY is called the ordered pairs. ordered pairs. These are called ordered pairs. So the cross product of two sets is nothing but the sets of ordered pairs. Sets of ordered pairs. That means set made up of the element of the ordered pairs. Right? So that is the thing. So definition you can see given two non-empty sets P and Q, the Cartesian product or cross product P cross Q is the set of all ordered pairs of elements from P and Q. Set of all ordered pairs of elements. If it is A, then A. If it is P, and then P, and B. Okay. So elements are coming from the two sets of what we are getting the cross product. Okay. Here it is written the Cartesian product. So Cartesian product, cross products are similar things. See, so I will show you why the Cartesian product also. Because when you are getting the uh, cross product of the two real numbers, uh, then you get the pairs of ordered pairs of the numbers, and that numbers can be plotted in Cartesian coordinates that will define the points. Okay, so cross product, Cartesian products are similar thing. So see, this is the definition of Cartesian product. Okay, so I hope that you understand. Now let us take the different examples to maybe it more digestive for you. So definition of Cartesian product is very easy. What you have to do is to take the two sets, right? If you want to check it practically, suppose we are having a set A that is having two, one, two, three elements. Okay, and you are having the element of set B as 4 and 6. Then you want to find the cross product or Cartesian product of two sets A and B. Then what you will have? It is the set. Cross product is the set of all the ordered pair of elements of A and B. Ordered pair of elements. So A cross B, not B cross A. A cross B, 1 and 4. One is, this is first element of this set, A cross B. 1, 6, 2, 4, 2, 6, 3, 4, and 3, 6. So this way we can find the Cartesian product of set A and set B. So that is easy. Okay. We can find different examples and solve the problems related to this. Here there is illustration like if suppose A is the set that is having the, now take the another example. This is one of the examples. Now take the another example. Suppose set is like that. It is the containing the element DL, MP, and K. If DL represents Delhi, MP represents Madhya Pradesh, K for Karnataka, and you want to find the number plates of vehicles with these symbols, and B is the 01, 02, 03 containing set, then generates a code for the license plates of vehicles issued by DL, MP, and Karnataka. So you are given this task that these are the sets, and you want to find the number plate, generated number plate, license plate with the help of this. So what you will do, you can find the cross product of set A and B. So you will get, and they see the condition DL is condition is that, see, if three state this making code for license plate with restriction. Restriction is that the code begins with an element from set A, which are the pairs available from the set, these sets, and how many such pairs will be there. So condition that key element should start begins with an element from set A. So the pairs first element of the pair should start from the set A. That means you have to calculate the A cross B, not the B cross A. The restriction is fulfilled in this way. So you will get DL01 first element of this cross product, DL02, DL03. So similarly, you will have MP01, MP02, MP03. Okay, and KA01, KA02, and KA03. So in this way, what you are having, that you are having the cross product or Cartesian product of set A and B. So you find the pairs of the number plate starting from this way. So available number plates, how many? So number of pairs can be given by the formula. Number of pairs, number of pairs of, suppose you want to find the cross product of A and B is given by, so number of pairs of A cross B is the number of elements in A into the number of elements in B. So you can imagine that number of elements in this example is 3 in the first, and number of elements in B is 3 also. So how many pairs we'll have in the cross product or Cartesian products in A cross B is equal to 3 into 3. That is 9. So 9 pairs total we'll have. You can also check from here. So we are having the 3, 3, and 3. Total 9 pairs, ordered pairs. Here ordered pairs means pair of X and Y is orderly restricted. The order is restricted. Ordered order is order of pair, order of element. Order of element is fixed. If you change the order of these elements X, Y, and Y S, so value will be different. Okay. So as a final illustration, consider the two sets A and B. Now, how the Cartesian coordinates are formed. You may be surprised, you have read these Cartesian coordinates many times, but have you thought anytime these Cartesian coordinates, how these Cartesian coordinates are formed? Suppose we want to draw the points in the xy plane, so we just, without thinking, we draw the two perpendicular number lines and we place the points uh, in this plane. So how, from where these ideas come from? To represent the particular place in the plane with the help of the Cartesian coordinate. So that is coming from the Cartesian products, right? Cartesian products. So suppose you are taking a set A that is containing the element A1, A2, A3, and so on, and you are taking the set P that is containing the element B1, B2, B3, and so on. Then, if you find the cross product of these two sets, you will get the set of ordered pair elements A1, B1, A2, B2, A3, V3. So, see, this is the beauty of mathematics. By the help of Cartesian products, we are getting the set of ordered pairs. So, set of ordered pair is the cross product or Cartesian products of the two sets, and their order is very much important, and they definitely represent here represent here the points in a 2D plane, 2D plane, right? So, no problem. See, so we find the pairs of numbers that act as the coordinate. Their order is important because if we want to locate A1 B1 and B1 A1, then their position will be different. So that's why their order very much matters. Okay. Now let us discuss some important points. Two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. Suppose you want to compare the two ordered pairs. Suppose you are taking A1 B1 and A2 B2. So it is saying that these two ordered pairs will be equal only if A1 is equal to A2 and B1 is equal to B2. So that is the thing. If and only if the first elements are equal, A1, A2 is equal, and second elements are also equal, then the order pairs will be equal. Second point, if there are P elements in A and Q elements in B, then there will be P into Q elements in the ordered cross product, Cartesian product, A cross B. So I have already told this. If A and B are non-empty sets and either A or B is an infinite set, then so is A cross B. So now let us take the another point. If A and B are non-empty set, and if any one of A or B is infinite set, then definitely A cross B will also be infinite set. So any one of A and B becomes infinite, then their Cartesian product will also be infinite set. So, and what about the, so when you are taking the cross product or Cartesian product of two sets, then the resultant you will get is called the doublet, because you are getting the A1, B1, A2, B2 are order pairs where there are two elements here. But when you are taking the cross product of three sets, then what? You'll get the set of three elements A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, so this is called triplet, and this result can be utilized for getting the Cartesian coordinates of points in 3D. Okay, so if you are taking the cross product of three set XYZ, then their cross product will represent give the Cartesian points of the 3D. Okay, so I hope that you understood the definitions and definitions of the cross product, Cartesian product, and the what how they can be represented as a set. Okay. Another thing what we are going to learn is the relation. So relations can be obtained from this Cartesian product by choosing particular pairs, ordered pairs out of the set of the cross product. Okay, if you are picking up the some uh, pairs as elements out of the cross product, then these pairs will have the relationship among these elements, elements, and then they will, if we make a different set, that is we are constructing a subset of that cross product, and that subset is having a special elements taking from the cross product, then these special elements uh, set, that is now the subset, is called the relation. Okay, so let us explain this with the help of some examples. So before that, let us solve this some basic problems that is given in your textbook. So we are uh, solving the problem from very simple to the uh, tough one. Let's say if x plus 1, y minus 2 is equal to 3 and 1, then find xy. Find x and y. Okay, so you are asked to find the value of xy. So you can see that these are the ordered pairs. So ordered pairs are equal only if first element of the both pairs are equal and second elements of the pairs is also equal. That means x plus 1 is equal to 3 and y minus 2 is equal to 1. First element is equal and second element is also equal respectively. So this will give x is equal to 2 and this will give x is equal y is equal to 3. So we are now having the xy values. Now similarly, if P and Q form the sets P cross Q and Q cross P, are these two products equal? So let us check this. The P is given as set of A, B, C elements and Q is the set of element R. So let us check whether P cross Q and Q cross P are same or not. P cross Q. So first element will be A R B R C R. These are the elements of the P cross Q. Now the elements of Q cross P R A R B R C. So you can see that total number of elements in P cross Q is equal to total number of elements in Q cross P. Number of elements are same, but their values are different. E, comma R order pair can't be equal to RA generally. E- They are different. Okay. If R and A itself are not equal to each other, then the pairs will definitely be different. So, since by the definition of equality of ordered pair, the pair AR is not equal to the pair RA, we conclude that P cross Q is not equal to Q cross P. So, these two sets P cross Q are not equal to Q cross P. Okay. So, that is the question number 2. Now, question number 3. So, you can do this. I will attempt one or two of this question 3. So now let A and B are given. So you have to find the example 3. A is given and B is also given. What is A? A is 1, 2, 3. 1, 2, 3. And B is what? 3 and 4. So, and the C is also given. C set is the 4, 5, 6. So it is asking find the values for A cross B intersection C. So see, we already have discussed these properties in the previous uh, chapter. Now it is coming into the this chapter. That means these chapters are interlinked. So information and knowledge of the previous chapter is going to be helpful in the coming chapters. So study properly. Don't skip anything. So how can you find this across B intersection C? For that you will find firstly the B intersection C. So B intersection C you can find from here 3B and C common. What is common? 4 only. So B intersection C is the set of 4. Okay, that is common to both. Now you can find A cross B intersection C easily. So A is the 1, 2, 3 and B intersection C is the 4. So you can have the ordered pair set that is what? 1, 4, 2, 4, 3, 4. So this is the answer. Similarly, you can find the other problems like A cross B intersection A cross C. Okay. So what you'll do? Firstly, you'll get A cross B and then A cross C. So for that, find A cross B. A cross B. So A cross B, 1 3, 1 4, total 6 elements, 2 3, 2 4, and 3 3 3 4. A cross B. Similarly, you can find the A cross C. A cross C, you can find A cross C. So elements of A cross C set is 1 4, 1 5, 1 6, 2 4, 2 5, 2 6, 3 4, 3 5, and 3 6. So see, this is the A cross B set and A cross C set. Now it is being asked to calculate their intersection. It is asking the intersection A cross B and A cross C. So what are the common is the intersection? So we'll write the answer A cross B intersection A cross C. So what are common? 1 3, find 1 3 in this. In no, 1 4, yes. 1 4 is common. So write the 1 4 element as a common. Now 2 3, no. 2 4, yes. 2 4 common. So write 2 4. Now next 3 3. 3 3, no. Next 3 4. 3 4. 3 4 common. So this is the 3 4. So that is the intersection of A cross B, intersection A cross C. So you can check the answer. 1 4 2 4 3 4. Okay. So in this way, you can calculate the cross sections, union, and all. So you can imagine here that how the information or knowledge of sets are useful in finding the Cartesian products and paired elements, pair numbers. Okay. So similarly, you can calculate 3 and 4. I am leaving you for this. Leaving you this for you. Okay. Now, beautiful example is the example number 4. So example number 4 is that if P is 1 and 2, form the set, form set P cross P cross P. Very good problem. So students may be surprised, how can we find this P cross P cross P? So P is given. So P is given. So that means you are taking 3 times P. Okay. Just for your the simplicity, I am showing this. You are taking 3 times P. Okay. So always this. Okay. Now you are being asked to find the P cross P cross P. So what we'll do? For simplicity, firstly find P cross P. Then you P cross P. Take let us take this and this. So you will get 1, 1, 1, 2, 1, 1, 1, 2. Now 2, 1, 2, 2. So this is the set P cross P. Now calculate P cross of this P cross P. So you are left, this is the P and this is the P cross P. So find P cross. So you are taking the priority of this. First element, first set is this P. 1, 1, 1. So what you will do? 1, 1, 1. Okay. 1, 1, 2. 1, 2, 1. 1, 2, 2. These are the elements. Now take the second element. 1, 1. 2, 1, 2. 2, 2, 1. And 2, 2, 2. So you can firstly verify the number of elements, whether the number of elements are coming as 2 into 2 into 2. That means total 8 elements should come. So count 1, 2, 3, 4, 5, 6, 7, 8. So total number of elements P cross P is equal to 8, as the number of elements in P is 2. So that is the thing. So you can see that our answer is matching with this. So in this way you can calculate the uh, Cartesian coordinates of the 3D plane. Okay. Now, if R is the set of all real numbers, what do the Cartesian products R cross R and R cross represent? So, similar example, this is the generalized form of this particular example 4. When the set of all real numbers, R is the set of all real numbers, then what the Cartesian product R cross R represents? R cross R represents the paired elements that can be taken as the Cartesian coordinates in the 2D plane. Similarly, R cross R represents the Cartesian coordinates of the 3D plane. So Cartesian product represents the set this, which represents the coordinates of all the points in the two-dimensional space. Cartesian product R cross R represents the set this and represents the coordinates of all the points in the 3D space. And here, beautiful example that the cross product is given. Cartesian products is given. A cross B. A cross B is given. That is PQ, PR, MQ, MR. That is the thing. Find A and B. So give A cross B is given and it is asking find A and B reverse. So you can find by uh, taking the restriction that pairs order is very important. So each element of the first pair, each element of the pairs, sorry, each element of the pairs belongs to the first set, that is A. Each first element of the pair belongs to the set A. So A is nothing but the set of P PQ, PR. P, PR, so M is P is being repeated. No, I will not write. P, M, bus. That is the thing. And B is the second element of this pair and that belongs to set B, second set. So that is QR. QR. So you can see here there are four elements A cross B and these are the two elements. So order is 2 into 2 will give the four elements of A cross B. That is verified. So that is the answer. A and B's values. Okay. I hope that you can do this exercise 2.1. It is very simple. For you, let us solve this exercise. If x plus 1, if x upon 3 plus 1 and y minus 2 by 3 equals to 5 upon 3, 1 upon 3, then find the values of x and y. We have done earlier in the example. So what you have to do that these are the paired elements. So you equate them and the first element equals to the first element of the second pair and second element of the first pair equals to the second element of the second pair. So x plus x upon 3 plus 1 equals to 5 upon 3 and y minus 2 upon 3 equals to 1 upon 3. So this will give x upon 3 equals to 5 by 3 minus 1 equals to 2 by 3. That means x is equal to 2. Similarly, this will give y is equal to 2 by 3 plus 1 by 3. That means 1. So you get the answer x is equal to 2 and y is equal to 1. Okay. So x is equal to 2, y is equal to 1. Similarly, if the set A has three elements and set B, then find the number of elements in A cross B. Set A has three elements and set B also has three elements. So find the number of elements in A cross B. So 3 into 3 that is 9 elements. So total answer is 9 elements. If this G is the set of 7, 8, H is the set of 5, 4, 2, find the GH and HG. You can do this. So this is very easy. State whether each of the following statements are true or false. If the statement is true, rewrite the given statement correctly. First problem is that if the statement is correct, then correct it. If it is wrong, then make the correct statement. If P is the set of Mn and Q is the set of Nm, then P cross Q. P cross Q will be M, N, M, M. M, N. Let us do on this side. So if P is equal to Mn, set of Mn, and Q is equal to set of Nm, then P cross Q. So P cross Q will find, so pair M, N, M, M, N, N, and Nm. So what is you are observing that Mn, Mm, Nn, Nm. So there is no repeating, there is no repetition of the elements. So this is the, and number of P cross Q elements are 4. That is also true. So true or false? So this is the false and the true is this one. If A and B are non-empty set, then A cross B is a non-empty set of ordered pairs such that X and Y X belongs to A and Y belongs to B. Yes, sure. So if A and B are non-empty sets, then their cross product, Cartesian product is a non-empty set. of ordered pair x and y, then xy belongs to C. That is the correct statement. True. If A is this much, B is this much, then find this. Let us do this question number 3. What is this? If A is set of 1, 2 and B is the set of 3 and 4, then find the A cross B intersection 5. Okay, prove that. You have to prove. So what you will do? First find the B cross B intersection 5. So B intersection 5. B intersection 5 means if 5 is the empty element, then intersection of B with 5 will also be empty. It will not contain the element. So that is 5. Okay, now A cross 5. This becomes 5, right? So this becomes 5. Now we are going to calculate A cross 5. So already we have read the properties of the Cartesian product, that if any one of the sets of the cross product is infinite, the total product cross product, yeah, Cartesian product will become infinite. If any one of the set of the Cartesian product is empty, then the Cartesian product will be empty set also. So this will give the empty set. So answer is true. So true. This is true. Okay, this is true. So you can find this. I already have calculated for P. Okay, so you can do this question number 5. If A cross B is this, find the A and B. I have also done for this. I have also done for you this. Find the separate set elements. So this is also easy. You can do this. Set question number 7. If A, B, C are given and D are also given, verify that this. Okay, so let us do this. That is elaborative. Question number 7. Question number 7. So let A is equal to 1, 2. A is equal to 1, 2. B is equal to 1, 2, 3, 4. 1, 2, 3, 4. C is equal to 5, 6. And D is equal to 5, 6, 7, 8. It is asking the find A cross B intersection C equals to A cross B intersection A cross C. You have to verify this. Okay, first question. So let us calculate LHS. A cross B intersection C is equal to A cross B intersection C will get B intersection C. Common between B and C. Only no common 1, 2, 3, 4, 5, 6. No common, that is 5. Empty set. So cross product of empty set will give the 5. So LHS becomes 5. Now RHS. A cross B intersection A cross C, that is equal to A cross B. Find the A cross B. So A cross B will be, uh, let us find separately A cross B. 1, 1, 1, 2, 1 3 1 4. Okay, 2 1 2 2 2 3 2 4. Okay, so this is the A cross B. Now find A cross C. A cross C. So 1 5 1 6 2 5 2 6. This is A cross C. Now you have to find the intersection of these two, intersection of A cross B and A cross C. So intersection here you'll get answer that let us check out the common between the two sets. 1 1 there is no 1 1 in this. 1 2 there is no 1 2, no 1 3. 1 4 2 1 no 2 1 2 2 no 2 2. 3 2 3 no 2 3. 2 4 no. So that means nothing is common. So that is the answer is 5. Okay. So this is verified. LHS is equal to RHS. Okay. And the second part is that A cross C is a subset of B cross D. So A cross C already we have found. Now for second part, third part, second part, A cross C already have found, and B cross D. B cross D this. So B cross D is 1 5 1 6 1 7 1 8 2 5 2 6 2 7 2 8 3 3. So there will be 16 elements. Okay, and so on. So you can see that A cross C, this is A cross C, and this is B cross D. 1 5 is given. You can see that this 1 5 is in this, 1 6 is in this, 2 5 is in this, 2 6 is in this. This means that B cross D is the bigger set and A cross C is the smaller set. That means A cross C is the subset of B cross D. Okay, so that is also verified. So, बच्चों, in this way, we will tackle the problems asked in the exercise. So, for solving these problems, what you need is that basic concepts and information related to the concepts. So, revise those concepts I have taught in this video. Uh, so you can do the problems. So, similarly, you can solve the question number 8. A is given, B is given, write A cross B. You can do how many subset will have A cross B? How many subset will A cross B have? So let us solve. So A subset, B subset. Take the cross product, that is Cartesian product. How many subsets will A cross B have? So you know the sub number of subsets, that is power set. It is asking actually the power set, that is 2 to the power number of elements of the cross product. So let us solve this. Question number 8, very good question. A is given, A is given. A is equal to 1 2 and B is equal to 3 4. So A cross B. So what will be the A cross B? Find the A cross B. So A cross B is equal to 1 3 1 4 2 3 and 2 4. So this is the set of paired elements. Okay, this is the Cartesian product of A cross B. Now it is being asked that how many subset will A cross B have. So you have to make the subset taking the elements from this set A cross B. So A cross B. So take the first, make the subsets of this. So subsets will be taking the elements from this set, that is 1 3. First subset 1 4, second subset. So there is no need to write all this. Answer is 1 2 3 4. Answer is 2 to the power 4. That is total 16 subsets. Total 16 subsets is the answer. But you can, how to 16 subset? So power set. Actually, it is being asked the power set. How many subset means find the elements of the power set. So that is the thing. So that is the formula 2 to the power number of elements of the set. You will get the total elements of the power set. So that is the, you can calculate this. So four subsets are already the four elements. Okay. So that is the thing. So these are the subsets. Now take the combination of two. So you will get the subsets 1 3 1 4. Again combination with this 1 3 2 3. Again combination with the last one 1 3 2 4. Okay. Similarly, you can have the three combinations together. Okay. So 1 3 1 4 2 3. This is one subset, right? Similarly, you can have the combination of three sets like this: 1 4 2 3 2 4. Okay. Now you can take the all elements together to form the subset. So next subset will be the set itself across B. 1 3 1 4 2 3 2 4. Now you can calculate the total number of subsets: 1 2 3 4 5 6 7 8 9 10. This is 10. Okay. Now what is the left with? You paired the 1 4 1 3 1 4 1 3 2 3 and 1 3 2 4. You have, the left one is the 1 4 2 3 1 4 2 3 1 4 2 3. This is the also subset 1 4 2 3, and another subset is 1 4 2 4 1 4 2 4. Okay. 1 4 2 4 1 4 2 3. So total subsets are now this much. So now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many remaining? Four others are remaining. So what other pairs can be made? You can think about. So we have taken the 1, 4, 2, 3, 1, 4, 2, 4. But what about the 2, 3, 2, 4? 2, 3, 2, 4. This is another subset. 2, 3, 2, 4 and 1, 3, 2, 3 already done. So that is 13. Now what are left? 3 sets. 1, 4, 2. So single sets, 4 subsets, 2 pairs. What is left? In subset, elements repetition doesn't matter. So there is no need to write the repeated element. Okay. See. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 1, 4, 1, 3, 2, 3. 1, 3, 2, 4. 1, 4, 2, 3, 11. 1, 4, 2, 4. Okay. 12. 1, 4, 2, 2, 4. And 2, 3, 2, 4. That is 13. Okay. And master one is the this one. Uh, Master means taking all the elements. So that will be the 14. And rest 2, 2, 2, 2. 3, 3, 3, and 3. So 1, 3, 1, 3, 2, 3, and this last. 2, 3, 2, 4, and 1, 3. That is 14 elements. Now the 2 others are left. So last one is the empty set. That is the